That's great. So just one question. Obviously, you're discarding quite a few potential therapies that are out there that could work for a certain subject. Do you believe down the road there will be a case where you said every cancer patient is different? Can a particular cancer patient comes in and you say, okay, this molecule and this compound in these variations will work for this particular person. That's it. Is this possible down in future down the road?
Well, so this is actually here already. So let me just give you an example. We have a colleague who's known by what's his name? Okay, Atal Bhute. He's the
Mm-hmm.
okay. Let me just write that in the chat. Maybe I can put
Mm-hmm.
the
Sure.
name
Sure,
later.
sure, sure.
So Dr. Bhute is the director at Biomed in University of California. So he got famous for using an antihistamine molecule. So,
Mm-hmm.
when we get allergy, so we use these antihistamines to suppress the immune system, right? So it's a very different purpose. So he used that molecule to to treat small cell lung carcinoma. So and with very high efficacy. So it's a different molecule which has a very different purpose, which is being applied to a very different disease, and the results were just amazing. So they were eventually given an FDA approval. So we call this drug repurposing. So if a drug has a purpose, we do not use that drug for that purpose, but we find a newer purpose for that drug. This is already there. So there are off targets that are available in the market. I cannot, I don't want to talk about them, but then people use it for their own efficacious ends, and it has worked. There was this guy, Dr. Martin, who's famous for his endeavors in AI. He got saved by a drug that was rejected in clinical trials, and he's doing very well. So there are stories of people who are healing themselves by looking at these data-driven models and fighting their cancer back.